All right, so we're back here for part 2. We just talked about the inside angle measure, which is going to be the average of the two arcs. Add the arcs, divide by 2. So the last scenario is if you have an outside angle. Now, we'll draw this here. Let's say you've got a circle, and I'm going to draw this time, these would be called secants. So a secant, S-E-C-A-N-T. They meet at this point here. That's your vertex. Now notice that this is outside the circle. We've got central angle on the circle, inside, and the last scenario is if we're outside somewhere. Let's say that when you trace this, you'll notice that this creates two arcs. It creates a big arc and it creates a little arc. So I'm going to use B for the big and L for the little. Let's say that the big arc is 120 degrees, and let's say that the little arc is 50 degrees. All right, so if the angle is inside, it's equal to the average of the arcs. If the angle is outside, it's going to be big minus little divided by 2. So inside is you add them, big plus little divided by 2. Outside is big minus little divided by 2. So what I'm going to do now is sing the song. If you're happy and you know it, and this is how I remember this, feel free to chant along, clap along if you'd like. If it's a central angle, it's the same. If it's on the circle, it's 1/2. If it's inside, then it's average. If the angle's on the outside, then it's big minus little over 2. All right, I stopped clapping there and decided to hit the desk. These are your 4 relationships. So the question is always, where's your vertex? If it's at the center, then that's going to be equal to the arc. If it's on the circle, it will be half the arc. If it's inside, it's the average of the arcs. If it's outside, you subtract them, big minus little, divided by 2. So let's go ahead and use this. We'll flip it back over. And we're at number 7 now. So we want to find x. And here's the angle x. X degrees. Now notice, where's the vertex, the point? It's outside. If it's a central angle, it's the same. If it's on the circle, it's 1/2. If it's inside, then it's average. If the angle's on the outside, then it's big minus little over 2. So here's your big arc, here's your little arc. We're going to subtract those and divide by 2. Big minus little, 146 minus 58, all over 2. We're going to subtract first. That's 88. Divide by 2. 88 divided by 2 is 44 degrees. That's your x. Big arc minus little arc divided by 2. Number 8. Okay, x degrees. Notice that the vertex is outside. Let's look at where it hits the circle, where it intercepts. Here's the arc 110, that's the big. Here's the arc 42, that's the little. So the outside angle is big minus little, 110 minus 42, all over 2. So we're going to subtract that, 68 divided by 2, you get 34 degrees. All right, number 9. Where's the angle? Here's x degrees. The vertex is outside again. Now we've got 2 arcs where it hits the circle. Here's the big arc, but we don't know that yet. Here's the little arc. To be able to calculate the outside angle measure, you have to know big, so we can do big minus little over 2. Now you'll notice that they do give you some other information though. They do tell you this arc here is 91. This arc here is 100, and think about all the arc measure of a circle. All the arc measures always 360. So if we add the arcs that we already know, 91, 75, and 100. Okay, so let's add those up. 91 plus 75 plus 100 is going to give us 266 degrees. Now we're looking for the big arc. That's what's left over. So these three add up to 266. To find what's left over, we'll subtract that from 360, and what we end up getting is 94. So 94 is your big arc. So now we can do, if it's central angle, it's the same. If it's on the circle, it's 1/2. If it's inside, then it's average. If the angle's on the outside, then it's big minus little over 2. Now that's 19 divided by 2, which is actually a decimal. It's 9.5 degrees. Yes, you can get decimals. That's okay. All right, so what happened there? You had to find that missing arc first, then you could do the equation. Now the last three here, number 10, what you'll notice is that here's an angle. The vertex is outside, but we already know the angle measure this time. It's 47. What we are missing is the big arc. That's your x, and then the little arc is the 63. Well, the process is the same. The outside angle is equal to big minus little over 2. So we're going to make an equation. X minus 63 over 2 gives you the angle measure, which this time we know is 47. Well, this is kind of like what we did at the top of the page. To solve this, let's put this over 1 and cross multiply. So 1 times x minus 63 is x minus 63 equals 2 times 47 is 94. To solve this, we got to move the negative 63. We're going to add it. And what we get, x equals 157. That's it. That's your answer. So the arc measures 157. You can check it. You can do 157 minus 63 all over 2, and you'll get 47. Number 11, find x. Okay, here's x degrees. Now let's see, 70 degrees is the angle. The vertex, where is it? Outside. So if I trace this now, that creates two arcs. It creates the 190, that's your big arc, and then it also creates the 70, that is your little, or I'm sorry, the x degrees, that's your little arc. So outside angle measure is big minus little over 2. So 190 minus x minus the little arc all over 2 equals the outside angle, which is 70. Well, how do you solve that? Let's put it over 1, make a proportion. So this will be 190 minus x equals 140. Now, we're going to move the 190. That's a positive 190, so we'll subtract it. We get, this is negative x. Don't forget, that is a negative symbol in front, equals negative 50. Normally, I would say we don't want to get negatives for an angle measure or an arc measure, but it's okay here because this is a negative 1x, so we go one more step, we divide by negative 1, and what that makes it is positive, so you get x equals 50. So the arc measure there is 50 degrees. Last example here, number 12. Here's x degrees, that's your angle measure. The vertex is outside. Now the thing is, when I trace this out, these are two tangents. This is a tangent. This is a tangent. And when they hit the circle, you'll notice that the big arc is all of this. We don't know that yet. And the little arc is 82. And by tracing this, I actually just traced the whole circle. So this is 82 degrees, but if I take the little arc and the big arc together, it's the whole circle, and all the arc measures are always 360. So to find the big arc, what's left over, I'm going to take 360 and subtract 82. That's going to give us 278 degrees. You can use a calculator if you need to. That's your big arc, 278. So the last step here, we want the angle measure. Outside angle is the big arc minus the little arc divided by 2. So we're going to subtract that. We get 196 divided by 2, which is 98 degrees. So the angle measure is 98. Now, this is the end of the notes, but I'm going to throw one more thing in here. You don't have to write this down. But I'm going to show you where these two formulas come from. Why is it inside? Why is it an average? Okay, why is outside going to be big minus little over 2? So for the inside, okay, there's the circle or something like it. And there's the angle measure. I'm going to call this here angle 1. And I'm going to name some points here. I'll call that A, B, and that's C, and that's D. And one thing that we can do here is I'm going to connect A to D. What it does, that creates a triangle. Okay, that's a triangle right there. And if we look at angle D, you'll notice, is on the circle. And notice that that is intercepting arc AB. Now, on the circle is always half of the arc measure. So angle D equals half the measure of arc AB. Whatever that is, whatever that number is, this would be half. Now, if I look at angle A, which is also in the triangle, angle A is also inscribed. The vertex is on the circle. If I trace that out, it hits the circle at arc CD. Angle A is on the circle, so it's half the measure of the intercepted arc. So angle C is half the measure of arc CD. Angle 1 is not in the triangle, but angle 1 is what we call an exterior angle. Angle 1 is equal to, we have a relationship that says angle 1 is equal to the sum of these two remote interior angles, angle D plus angle A. Angle 1 is equal to angle D plus angle A. Well, angle D is 1/2 arc AB plus angle A is 1/2 arc CD. I can factor out the 1/2. So I get angle 1 equals 1/2 times arc AB plus arc CD. And instead of multiplying by 1/2, what I'm going to do is say angle 1 equals arc AB plus arc CD over 2. Add the arcs, divide by 2. That is what we call the average. So that's a proof of why this formula actually works. Why is an inside angle equal to the average of the arcs? There you go. For the outside, okay, kind of running out of time here, but for the outside angle, if you are curious, I'm going to do kind of the same thing here. I'm going to draw those two angles, and here's our measurement here. We can call that angle 1, and let's see, here are points A, B, C, D. And what's going to happen here, I'm going to connect point C to point B, like that. And let's see, so that gives us angle, here's angle ACB, and in the triangle, here's angle B, right there. I'll put 3 arcs for that. Now, you'll notice that angle B is equal to half of arc CD, because it's inscribed on the circle, is half the measure of arc, whoops, I'll just say half arc CD. Angle ACB, I'll just say angle C, is going to be half of arc AB. Okay, angle ACB intercepts arc AB. And then what happens here is that angle 1 is an interior angle, so is the angle B. Angle C, ACB, is the exterior angle of this triangle. So angle ACB, or angle C, is equal to angle 1 plus angle B. But I'm trying to solve for angle 1, so I can subtract angle B, and that's going to be angle C is 1/2 arc AB minus 1/2 arc CD. I'm going to write that as arc AB minus arc CD over 2. That's equal to angle 1. And that's the big arc minus the little arc divided by 2. So that's the proof. And that is the end of the notes.